What's up guys? In this video, I'm going to talk about a shortcut that I've stumbled across myself. And what's interesting is I haven't actually seen this done in any other video on YouTube. I looked far and wide just out of curiosity because I thought to myself, surely someone else has done this. But to my knowledge, I can't find this strategy for calculating the float time of an activity anywhere. So if you watched my last video in this playlist, you would have seen that in order to calculate the float time, you've got to find earliest start time, latest finish time, and then go and do some calculations from there. So for that reason, I'm calling this the Woolway algorithm because this is a way to find the float time and with a much easier approach that takes a lot of less calculating and less thinking and less formulas. There's essentially no formulas required. You've just got to do forward scanning and backward scanning. I've called it the Woolway algorithm because that is my last name, and I genuinely think that I could have actually found something here that, to my knowledge, hasn't been done before by anyone else. I could be wrong, but to my knowledge, I stumbled across this myself. I was looking deep into this, so let's get straight into it. Now, this is the most important thing, right? So as we know, the critical path is always the path with the same numbers in each node. So in this case, it's going to be from B to E to H to J because all of those nodes have the same number. That means the critical path is B, E, H, J. It also means the earliest completion time of this whole activity is 24 minutes. That number is important. That is going to be very important to us for this shortcut. So let's just assume that all of these activities are in the units hours for this video. Now, this is the Woolway algorithm. To find the float time of any activity, find the second best critical path that includes the activity in question or the activity that you're trying to find the float time for. Then, once you've done that, subtract the total time of the second best critical path from the earliest completion time. The earliest completion time is just 24 hours. So for example, let's say I wanted to find the float time of activity A. So I'm going to have to go towards activity A first because I have to include that activity. Now I'm going to find this second longest path because the critical path is always the longest path. So I'm going to go along the top there because 3 and 8 is longer than 4 and 5. Then I have to go through I, and then I've got to obviously go through J. Now, if I add up that's 4 plus 3 plus 8. So that's 7 plus 8, which is 15. 15 plus 3 is 18. 18 plus 2 is 20, right? Now, if I just do the earliest completion time, so 24 minus the second best critical path involving the activity that I'm trying to find the float time for, then that would be equal to 20. So 24 take away 20 is obviously 4 hours, which if you watch my last video, that is correct. And I've checked this many, many times just to double confirm that this always works. And to my knowledge, through what I've checked, it always works. Let's do it for activity G. So for activity G, if I want to include activity G, I've got to go through A, then I've got to go through D, then now G. So G is now being included in the second best critical path. Then I've got to go through I and then through J. So if I add up all of those edges, we've got 4 plus 4 is 8, plus 5 is 13, plus 3 is 16, plus 2 is 18. So 24 take away 18 would give me 6. So activity G has a float time of 6 hours, meaning activity G can lag by, say, 5 hours, and it's not going to impact how long it takes to complete this entire activity. Let's do one more example using the float time for activity F. So in order to go past F, I've got to go from A, then to C, then to F, then to I, and then to J. So if we calculate the second best critical path involving activity F, we've got 4 plus 3 is 7, plus 8 is 15, plus 3 is 18, and then plus 2 is 20. So we've got 24 take away 20 gives us a float time of 4 hours. You can double check this yourself. I think this is a much easier approach to finding float time. It's essentially a way to find the float time of any activity after you've done forward scanning and backward scanning without the use of any formulas whatsoever. The only catch here though is that I guess in exam situations, you may need to be required to show formulas. But if you had like a multiple choice question, for example, that was asking what the float time was for an activity, then you can definitely use this method. Or if you've got a question on the external exam that's maybe just a 1 mark question, 1 mark means that you don't have to show a whole lot of working out, you just have to write the answer. Then the Woolway algorithm, would be completely fine. But definitely double check with your teacher around what their expectations are, and also have a good look at the past external exam solutions to double check what the required working out is when you're finding the float time. That's it for this video, guys. Thank you for watching.